Okay, time to continue. Right. First step is the same, find the coordinates of the center. We know that's 0, 0 because the equation of the circle is in the form x squared plus y squared is equal to r squared. Right. So we're done with that. 0, 0. That's the center. Step 2, also the same. Find the gradient of the radius using the given point and the center. So in this case, I use this one as x2 and y2, and the center as my x1 and y1. So that's why I have y2, which is 2 in this case, 2 minus y1, which is 0. So 2 minus 0 divided by x2, which is 1, minus x1, which is 0. 2 minus 0 is 2, 1 minus 0 is 1, and 2 divided by 1 is 2. So the gradient is 2. That's the gradient of the radius. Hold on, admitting people. Right. Those are the same steps from before. This is where it changes. Third step, instead of finding the gradient of the tangent, we try to find the gradient of the normal. But I need you to remember that the gradient of the radius is equal to the gradient of the normal. The gradient and the normal, they have the same, the radius and the normal have the same gradient. So since the radius has a gradient of 2, that means that the gradient of the normal is also 2. Everybody good with that?
Yes, miss.
Okay. The third and fourth step, well, actually not even the fourth step. Why do I have tangent? Anyways, I'll change that of the normal. It's really only the third step that changes, because in the fourth step, you're still using these two, well, one of them, to find the equation, right? So third step, find the gradient of the normal, and we know it's the same as the gradient of the radius, so it's 2. Step 4, why do I have step? Anyways, step 4, find the equation of the normal using y is equal to mx plus c, or this one. Remember, if you need to review that, just look at this. Okay. Now let me show you how I got this answer. What was the center? Right, center 0, 0, given point 1, 2. We just found out that the gradient, so m, of the normal is 2. We have the two methods. So use y is equal to mx plus c, or you could use y minus y1 is equal to m in brackets x minus x1. We'll use that one. It's equal to m in brackets x minus x1. For the normal, oh my gosh. Anyways, we pretend that's a circle. Purple is the given point. Green, blue. Blue is the normal. Capital N for normal. Yellow is the tangent. Oh, I didn't even touch the kicks. Anyways, T for tangent. What I need you to notice, the normal, let me extend this line a bit. Wrong color. Sorry, yeah, bear with me. So extending this line. All of this whole blue line is the normal. What I need you to notice is that the normal passes through the center here. But unlike the tangent that only passes through this one point, this purple point right here, the normal passes through the center and it passes through that point. If I extended this line here, you could tell that it passes through the purple point. Right. So it passes through the center and it passes through that point. So what I'm trying to explain here now is that unlike when you're finding the equation of the tangent, when you only had to use this point, that's the only point you could use for the tangent. However, since the normal passes through both the center and this given point, you could use either one. Let me show you that now. So you could use either point when finding the equation of the normal. Now let me prove that, because if I can't prove it, why should you believe it? Okay, you put back your y. Let me use yellow. You put back y. I want to use this point first, my given point. So this is x, this is y. y1 is 2, is equal to m, which is 2, put back the x, minus x1, which is 1. Now we need to make y the subject of the formula. So this becomes y minus 2. I could expand these brackets to get 2x minus 2. I need to add 2 on both sides. So I'll end up with, let me use screen. Y is equal to 2x minus 2 plus 2 is 0. And that's why the equation of my normal is y is equal to 2x. And I mean, it makes sense. Why? For the people who weren't here, don't worry. Google Classroom is the way to go. Right. It makes sense because the people who were with me or people who did this in class already, like in school, you know when a line passes through the origin. So say this is y and this is x. If a line passes through the origin, which is this point here, 0, and it has the coordinate 0, 0. That's what the origin has, coordinate 0, 0. My line passes through there. It's in the form y is equal to mx. Somebody might be wondering, I thought this was the general form of a line. Where is the plus c? But what you need to remember from previous classes as well, c is the y-intercept. Y-intercept means wherever the line cuts the y-axis, which is this vertical line. I need to notice that this line, this red line here, does not cut the y-axis. So it has no c, or c is equal to 0. But if something is equal to 0, so like if I had y is equal to 5 plus 0, we know that 5 plus 0 is 5. So there's no need to put plus 0. So that's why there's no need to put plus c. And when the line passes through the origin, which has the coordinate 0, 0, is only in the form y is equal to mx. The plus 0 is understood. So just recapping that, right? And that's why it makes sense that this equation is y is equal to 2x without a plus c, because it passes through the origin. That means it does not cut the y-axis, and it does not have a c. Everybody good with that?
Excuse me.
Yeah.
So at all times, the equation of a normal will always be in the form y equals to mx.
No. Every time though, every time the center is 0, 0, you see center 0, 0, you know that your equation for the normal is going to be y is equal to mx. If you don't understand, let me know.
Oh, okay, miss. Understand now. Thank you.
Okay. So that means if you see center equals 0, 0, and you get a plus c, you know something wrong and you need to go check that again. So I wanted to prove to you that you could use either point for the normal. Let me just continue down here. So this is one method. Cool. Next method. Actually, let me use the same method. So the same y, x1. But in this case, instead of using the given point, I'm going to use the center. I'm going to use the center. So y minus 0, because this is x1. Well, this is x and this is y. So is equal to m, which is 2, put back your x, minus x1 is 0. Y minus 0, that's just y. I could expand these brackets. 2 by x is 2x. But any number by 0 is 0. And notice, same answer. This one up here, I used the given point and I got y is equal to 2x. This one down here, I used the center and I still got y is equal to 2x. So that was just to prove to you, use either point when finding the normal, remember that, not tangent, normal. When finding normal, you could use either point. So, how was that? Good, bad? You don't know what's going on?
I understand everything.
Ah, yes, nice, nice. Anybody who did not understand, let me know, please. Okay. That was just a proof to you, because if I can't prove what I'm saying, you should not believe me. Same goes for everybody. If they cannot prove what they're saying, don't believe. That's very good. Okay. Okay, let's do this question. We're doing this. I'll go through this one with you, and then you could try the others by yourself first, and then we would go through it. So, hold on. Let me just find the question. All right. They want you to find the equation of the normal as well. In this case, they gave you that the equation of the circle is this: x squared plus y squared minus 2x plus 4y minus 20 is equal to 0. And they told you that the normal passes through this given point and has the coordinates 5, 1. First step. Remember, the first two steps are the same. First step, you want to find your center. You need to realize that this equation that they gave us is in the general form. And the general form we know is x squared plus y squared plus 2hx plus 2ky plus c is equal to 0. And how do we find the values of h and k when given the general form? We use these formulas. H is equal to the coefficient of x divided by 2. K is equal to the coefficient of y divided by 2. What does coefficient mean? The coefficient of x is the number or the terms that come right before x. So in this case, minus 2 is in front of x. So my coefficient of x is minus 2. That's why I would put here minus 2 divided by 2, which is equal to minus 1. So h is equal to minus 1. Now we do the same for k. Coefficient of y divided by 2. The coefficient of y is the number that comes before y. In this case, it's 4. Positive 4. So we put that equal to coefficient of y. You put your 4 divided by 2 is 2. But that's the value of k. We know that the center, let me use red, the center, this dot here, has the coordinates minus h and minus k, right? So let me erase something. Let me erase this. We know the center has the coordinates minus h and minus k. So center has the coordinates minus h and minus k. If h is minus 1, that means, okay, let me just, gosh, I need space. Okay, let me just continue. In white. If h is minus 1, so let me put it here in purple. If h is equal to minus 1, that means, therefore, minus h has to be equal to 1. So I'll put 1 here. If k is equal to 2, that means that minus k would be equal to minus 2. And this is my center. Everybody good with that?
Yes, miss.
Okay. If you don't understand anything, let me know. All right. Great. So now we know that the center is 1 minus 2. If you don't understand something, remember to let me know. I am here to help you. So I will help you. Erase. Hold on now, bear with me. Can anybody tell me what the second step is? You don't have to talk, you could type in the chat.
To find the gradient of the radius.
Good job. Find the gradient of the radius of, I'll just put r. Anybody could tell me what's the formula for the gradient?
Y squared, y2 minus y1 over x2 minus x1.
But some people don't learn like this, huh? They might learn the difference in my y values over the difference in my x values, or you might see change in y and change in x means the same thing. All right, this is just to help you understand, to identify your y1, your x1, y2, x2, substitute, done. This is just for your understanding, right? Okay. So when finding the gradient of the radius, we remember we need to use the given point and we need to use the center. So I just want this one to be, oh no, that's not y. My bad. That would be x. I want this to be x2, this to be y2. I want this to be x1, and I want this to be y1. But remember, they're interchangeable. So this could have been your x2 and y2, and this as your x1, y1. It's your preference. So y2, in this case, is 1. So I put my 1 there, minus y1, which is minus 2. So that's 1 minus minus 2. Don't let them trick you. Next one, x2, which is 5. So I put 5 there, minus x1, which is 1. So that's 5 minus 1. 1 minus minus 2, that's the same as 1 plus 2, because a minus and a minus is a plus. We know that. And 5 minus 1 is 4. So now what we have here, 1 plus 2 is 3, on 4. And this is my gradient for R. Everybody good with that?
Yes, miss.
Okay. Can anybody tell me what's the third step?
To find the gradient of the tangent.
We're trying to find normal in this case. So find gradient of the normal, yeah. Actually, I'll make you do the tangent as well, but after we do the normal. So the third step when finding the normal is grad. Grad means gradient of normal. Just put capital N. Can anybody tell me what's the gradient of the normal? We know that R is 3 and 4. So what's the gradient of N?
Three over four.
Good job. Why? If anybody is wondering, because the gradient, so just put grad of the radius is also the grad of the normal. And that's why the gradient of the normal is also 3 and 4, 3/4. Okay, fourth and final step. Can anybody tell me what it is? What's the fourth step? Anybody?
Find the equation.
Find the equation. Good job. Remember, you can use any point when finding the normal. Normal. You could use the center, you could use the given point. So let me use y is equal to mx plus c in this case. Remember, you could use the other method as well. I want to use the given point. So y is 1 is equal to m, which is 3/4, x is 5 plus c. We're trying to find what c is. So 1 is equal to 3/4 times 5, that would be 15 on 4 plus c. Now that would be 1. I need to minus 15 on 4 on both sides. So 1 minus 15 on 4, that would be minus 11 on 4, which is equal to c. And I could rewrite this now. Why am I rewriting it? Because the general equation of a line is y is equal to mx plus c. That's how I need to write my answer. So y is equal to m. We know that m is 3/4. The gradient of the normal is 3/4. So I put back down x. And we know that c is minus 11 on 4. So I put minus 11 on 4. Everybody good with that? Yes, no?
Yes, miss.
Yes, miss.
Okay. Let me just use, okay, this is the last time. I would just use the other point. This is the last time I would take the time to use both points. But I just want you to understand that you can use both points and get the same answer. I need to prove what I say. Otherwise, I'm telling you not to believe me. If I cannot prove what I'm telling you, don't believe me, right? So I told you that you could use either point and get the same answer. So let me just use the same one. Okay, now I'm using the center instead of the given point. Y, in this case, is minus 2, is equal to m. M, which is the gradient of the normal, is still 3/4. So I put back my 3/4. X in this case is 1 plus c. Minus 2 would be equal to 3 and 4 plus c. I need to make c the subject of the formula. I need to get c by itself. And how do I do that? I need to minus 3/4 on both sides. Minus 2 minus 3/4 is minus 11 on 4. Anybody who wants me to prove that as well? No problem. Minus 2. If I wrote this as a fraction over 4, it would be equal to minus 8 on 4. Minus 8 on 4 minus 3 on 4. The denominators would remain the same. And -8 minus 3 is -11. Just in case anybody wanted me to prove that, you could put that in your calculator as well. Doesn't matter. But yeah, just in case you wanted me to prove that as well. And rewrite it as a, and you'll get the same answer. Y is equal to 3 and 4x minus 11 on 4. Okay. Everybody good with that, right?
Yes, Miss.
Okay. That was just to prove to you that you could use both points. Okay, past paper questions now. All right. We didn't share yet. Eraser. Oh no, I want you to find the tangent. Okay, you do another question again. So this is what we're doing now. Paper 2, 2015, number 3, part 3. Let me show you it now. I will send this to you at some point, so you don't need to write down the question. You could just write down this, write down the number, and you're good to go. So this is what we're doing right now. We did these two parts already in a previous class. So if you want to see that, just look at the recording. But you don't need these two parts to do this.
Excuse Miss.
Yeah.
This is my first time joining, and I would like to know the time you're finishing, since I might have to leave at 7.
7. I finished at 7.
Yes, Miss.
This will be the last question because I don't want to go over time. All right, I'll give you 2 more minutes for this, and then I'll go through it because I don't want to go over the time. Okay, let's go through this one now. So the first thing you want to do for any question, write down all the information that they gave you. So they told us that this is the equation of the circle, and they also gave us this point. Okay, 1 point. They told us that the normal passes through this point. Each of 1 point is 4, 10. So first thing you do, write down all the information that they gave you. The steps now. Can anybody tell me what the first step is?
Find the center.
Yes, good job. Can anybody tell me what they got for the center? What you got for the center?
6, 11.
6, 11. Anybody else got 6, 11? Anybody else got that? Yes or no?
Yes, miss.
Okay, well, everybody who got that, good job, because that's right. So firstly, not first thing, you need to notice that this is the general form. We know that this is the general form. X squared plus y squared plus 2hx plus 2ky plus c is equal to 0. And we know when given the general form to find h and to find k, h is the coefficient of x and 2, k is the coefficient of y and 2. Coefficient of x, that just means the number that comes before x. In this case, it's minus 12. Not just 12, huh? Minus 12. So what I put in here to find x, minus 12 divided by 2, which is equal to minus 6. Now we need to find k. K is the coefficient of y divided by 2. Coefficient of y is the number that comes, okay. The coefficient of y is the number that comes right before y. In this case, it's minus 22. Not just 22, minus 22. Don't make that mistake. Minus 22 divided by 2, which is equal to minus 11. However, we know that the center has the coordinates minus h and minus k. Not h and k, minus h and minus k. So if h is minus 6, that means that minus h has to be 6. If k is minus 11, that means that minus k would be equal to 11. And that's why this answer here is correct. If you don't understand, stop me. But I'm continuing now. Can anybody tell me what the second step is?
To find the gradient of the radius.
To find the gradient of the radius. Good job. So can anybody tell me what they got for the gradient of the radius?
A half.
A half. Anybody else got a half?
Yes, miss.
Okay, so everybody who got a half, good job, because that's the right answer. The gradient of r, which is the radius, is a half. So I'll just put m. Remember, m means gradient of r. R is radius. We know the equation for the gradient is y2 minus y1 over x2 minus x1. I want this to be x2 and x1. I mean, x2 and y2, and this to be x1 and y1. So I'll just substitute my values. Y2 is 11, so I'll put 11 minus y1 is 10, put your 10, divided by x2. X2 is 6, x2 is 6, so you put your 6 there, minus x1 is 4. 11 minus 10 is 1, and 6 minus 4 is 2. And that is why the gradient of the radius is a half. Remember to stop me if you're confused about anything. Anything at all. Third step. Can anybody tell me what's this third step? We're trying to find the normal. Anybody? What's the third step?
Find the gradient of the normal.
M means gradient of capital N for normal. And what's the gradient of the normal? What you get for your answer? A half. And for anybody who does not know why, we proved before that the gradient, grad means gradient, of R, which is the radius, is the same as the gradient of N, which is the normal. So since the gradient of R is a half, the gradient of N would also be a half. And that's why that answer is correct. Fourth and final step, find the equation. In this case, we're trying to find the equation of the normal. We know there are two ways to find the equation. Oh my, bear with me. We know there are two ways to find the equation. We could use this way, y is equal to mx plus c, or we could do it this way. Y minus y1 is equal to m in brackets x minus x1. I'll be using the second one. Remember, when finding the normal, not the tangent, the normal, you could use either point. You could use the center, or you could use the given point. Okay, I just need to end this and start it over just to finish this question, and then we could all leave. But we have less than a minute, so you need to leave and rejoin.